Why, hello, hello. It's Mrs. Wisniewski here. So I am going over the homework that was due today, Unit 5, Lesson 4. This homework is really important that you follow along or check your answers or both because you have a quiz on Friday. So when it says factor completely, there is a very, very, very large chance that there's more than one method here. Please refer to that little sort of cheat sheet we made the other day with the methods on it. Looking at 1A, I can tell that there is a GCF of 2. So I'm going to divide everything by 2. And I'm left with x minus 7x minus 18. Now I have a trinomial. 1 times negative 18 is negative 18. Well, what multiplies to negative 18 but adds to negative 7? Negative 9 and a positive 2. I'm going to carry that GCF along out front. So x squared minus 9x plus 2x minus 18. Now I'm going to do the ever so familiar factor by grouping and carry that GCF along. Okay, and when I divide everything by my GCF of just those two terms, I get x minus 9. And here, my GCF is a positive 2. And when I pull that out, I get x minus 9. Carry that 2 along. My new GCF is x minus 9. And I'm left with x plus 2. All right, part B. Looks again like I have some type of GCF. It's probably 5, right? And it is. So my GCF is 5. And when I divide everything by 5, I get x squared plus, let me get my handy dandy calculator so I don't make any mistakes, 14x plus 49. Ooh, I know what this one's going to be. I am going to now factor a trinomial. 1 times 49 is 49. Well, what multiplies to 49 but adds to 14? Well, it's 7 and 7. So I'm going to replace my two middle terms by 7. And now I'm going to do factor by grouping. Don't forget to carry along that 5. So my GCF here is an x, and I'm left with x plus 7. My GCF here is 7, and I'm left with x plus 7. So my new GCF is x plus 7, and I'm left with x plus 7. If you want to get fancy, nope. You want to write that binomial and put squared there because there's 2 of them. Part C looks a little different, but I do still have a GCF of 3. When I divide that, I end up with x squared minus 64. Now, I don't have a trinomial this time, I have a binomial, so I'm going to look at my other methods, and this to me looks like a difference of perfect squares. So that method is 2 binomials, 2 sets of parentheses, 1 plus, 1 minus. Everything else should look the same aside from the plus and the minus. I take the square root of x squared, that gives me an x. I take the square root of 64, that gives me an 8. And voila, you are done. So in D, let's see, I think I have a GCF of 6, right? Let me just divide 96 by 6 to make sure it goes in evenly. It does. So my GCF is 6, but I also notice that I have a variable in all 3 terms. So I'm going to take the lowest exponent. So my GCF is 6x. I'm going to divide everything by that and put that out front. And I'm left with x squared plus 6x minus 16. Okay, now we're back to the trinomial. Well, 1 times negative 16 is negative 16. What multiplies to negative 16 but adds to a positive 6? That would be 8 and negative 2. So I'm going to replace my 2 middle terms with that. Now I'm going to do a little factor by grouping. My GCF there is an x. And when I divide that, I'm left with x plus 8. My GCF here is 2, but it needs to be negative because of this sign here. It should match in the second term. I'm going to put a minus 2 there, and I'm left with x plus 8. That will ensure that what's in my two sets of parentheses should match. And bring down my 6x. I have an x plus 8 out front. That's my GCF. Then I'm left with x minus 2. Now, in looking at that, and really what you should say at the other ones is, do I have any other methods left? No GCF, they're not a difference of perfect squares, and they're not perfect cubes. So that means you are done. E. All right, let's see. It looks like I have a GCF, right? Between 28 and 7, my GCF's got to be 7. And I do have a variable in each term. The lowest exponent is 1. So my GCF is 7x. I'll divide everything by that. And I'm left with 4 minus x squared. Now, let's see, do I have any other methods? This is a difference of perfect squares. So 2 sets of parentheses, a plus and a minus. Now do not change the order of the binomial. We're used to seeing the x first, but you can't change the order when you're subtracting. So it should look like that, and you're done. Part F also has a GCF. Notice a common thread here. To me, let's see, between 8 and 12, I have 2 and 4. 4 is greater. So my GCF is 4. And I'm left with 2x squared plus 3x minus 2. Now I need to multiply my first and third term together. That gives me a negative 4. There isn't a 1 there, right? So be careful. So what multiplies to a negative 4 but adds to a positive 3? Well, it's going to be a positive 4, negative 1, right? That's going to multiply to negative 4 when yes, okay. So I'm now going to replace my middle terms with that. And now I'm going to do factor by grouping. So my GCF here is going to be a 2x. And I'm left with x plus 2. Now, there's no GCF here. So when there isn't a GCF, you do still have to pull something out in order for this method to work. So I'm going to pull out a 1. But now if I divide everything by 1, I'm going to end up with a negative x minus 2, which doesn't match what's in the parentheses. I need to pull out a negative 1 for that reason, and for the reason that, again, the sign should match there. And then when I divide that, I end up with x plus 2, which is what I really wanted anyway. So x plus 2 is my new GCF, and 2x minus 1 is what is left over. Beautiful. Number 2, write each of the following in completely factored form. Same directions. I don't know, they just like to make it look confusing. All right, do I have a GCF there? Well, I have a 15. Will 15 go into 110? No. Okay, so then it must be 5, right? So I'm going to divide, my GCF's got to be 5. Whoops. GCF has got to be 5. Divide everything by 5. Put my 5 out front. So I have 3x minus, I think that's 22, but I'm going to double check. Yep. And that is 24. Now I'm going to multiply, because I have a trinomial, 3 times 24, which is 72. Now 72 has a lot of factors, and you want the pair that adds up to negative 22. So if you need to, in your y equals, type in 72 divided by x and go to your table and look for the pair that adds up to a negative 22. I'll give you a hint. They're both negative. They've got to be, don't they? I got negative 18 and negative 4. So I'm gonna replace my middle terms there. Factor by grouping. Are you guys tired of this yet? And my GCF here is gonna be 3x. And I'm left with x minus 6. My GCF here is gonna be a negative 4. Left with x minus 6. My new GCF, x minus 6, and what's left over is 3x minus 4. And there we are. Part B, I definitely have some sort of GCF. 10, 26, and 12, so it's going to be 2. Again, if you're struggling with GCF, you need to send me a message because I'm just kind of flowing through the GCF part of it because I'm assuming you do know how to do it. But if it's tripping you up, you got to let me know. They all have x's also. The lowest one is x to the first. So my GCF is 2x. Put that out front. And I'm left with 5x squared minus 13x minus 6. Okay, now I have a trinomial. 5 times negative 6 is negative 30. They also have negative 30 has lots of factors, so you might want to put that in your y equals. But for me, I believe it's negative 15 and 2. So I'm going to replace my two middle terms. Now I'm going to do factor by grouping. 5x, 2x. And I'm going to do times my GCF of 5x, and I'm left with x minus 3. My GCF on the second half is a positive 2. I'm left with x minus 3. Keep bringing along that 2x. Your new GCF is x minus 3, and I'm left with 5x plus 2. And there we are. All right, 3A, completely factored, reach of the following. Okay, so do I have a GCF? At first glance, 39 is a tricky number. It kind of looks like it might be prime, but it's not. There is a GCF of 3. 3 goes into 39 evenly. So it's going to give me a 6x squared minus 13x minus 5. Now I'm going to do factor by grouping again. Negative 30. Oh, this looks awfully familiar. So negative 15 and a positive 2 multiply to negative 30, but add to a negative 13. So I'm going to replace my two middle terms there. Minus 15x plus 2x minus 5. And now when I do factor by grouping, my GCF here is 3x. So I'm going to put my 3x here, and I'm left with 2x minus 5. And in the second part, it's exactly the same number there already, and there is no GCF, which means I'm only going to pull out a positive 1, and that's going to give me 2x minus 5, and I do have a GCF. And I'm left with 3x plus 1 in my parentheses, and that is the final answer. On B is looking a little different, but let's see. So my GCF between 45 and 20 is going to be 5, but they also have x's. X to the 1 is the lowest exponent. So I'm going to divide everything by 5x. Put it out front, and I get 9 minus 4x squared I'm hoping that you recognize that this is a difference of perfect squares, plus and a minus. Again, don't change the order. So the square root of 9 is 3, that goes first. The square root of 4 is 2, that goes after the sign, and then the square root of x squared is x. And that is the final answer there. All right, on the next page, let's see if these get a little bit more complicated. I don't know. They seem like the same thing over and over again. All right, GCF in C. It could be a 2, it could be 4. No, 4 does not go into 30 evenly. So it is 2. Divide everything by 2. I get x squared plus 15 plus 15x plus 14. So I am now factoring a trinomial. 1 times 14 is 14. What multiplies to 14 but adds to 15? If you're thinking 2 and 7, you're thinking incorrectly. It's 1 and 14. I'm going to replace my 2 middle terms. And do factor by grouping again. So in the first two, my GCF is an x, and I'm left with x plus 1. In the second one, my GCF is 14. And when I divide that, I'm left with x plus 1. So my new GCF is x plus 1, and my last is x plus 14. There we go. D, let's see, about a GCF. I'm going to say it's a 10. And I have x's everywhere, so my lowest exponent is 1. Divide everything by 10x. And put the 10x out front, and that's going to give me 9x squared minus 9x plus 2. Another trinomial. 9 times 2 is 18. What multiplies to a positive 18, but adds to a negative 9, negative 3, and negative 6. Replace that. Now I'm going to do factor by grouping. And here I got 3x as my GCF. So times 3x, I'm left with 3x minus 2. And I almost have the same thing here, which tells me to pull out a negative 1. And I have 3x minus 2. So 3x minus 2, and then 3x minus 1 is what is left over. E says I have a GCF of 3. Divide everything by 3. I don't know why I just canceled cross that off. So that's going to give me 9x squared minus 1. Looking at this method, I have a difference of perfect squares. Plus and a minus. The square root of 9 is 3. The square root of x squared is x. And the square root of 1 is 1. Those cannot be factored any further. So that is your final answer. On F, looks like I'm going to have some type of GCF. Let's see, 20 only has 4 and 5. So it's going to be 4. Divide everything by 4. That out front, and I have 5x squared plus, let me double check that on my calculator, don't want any mistakes, 112 divided by 4 is 28x minus 12. Okay, I got another trinomial. When I multiply these together, I got negative 60. Now, this is a good time to use your y equals. 60 has a lot of factors. You're going to look for what adds up to a positive 28. And it's a positive 30 and a negative 2. So replace the middle term and do a little factor by grouping here. So my GCF here is going to be 5x. And that's going to give me, when I divide that, x plus 6. Here, my GCF is a negative 2. And when I divide, that gives me an x plus 6. 5x minus 2. There we go. Okay, so problem G, I just did like, I don't know, 4 times off camera, and it's not working out. I feel like something should be changed to a minus, but I'm gonna show you why it doesn't work out, and then I'm just gonna stop and say it's not factorable. So there are 4 terms here. There is no GCF. So I'm gonna hop right into factor by grouping. It's already got my 4 terms, right? So my x squared is my GCF. And when I divide that, I get 5x plus 4. Now right here, my GCF is a minus 9, right? Now when I divide that, I get 5x minus 4. These do not match. I believe that either this is supposed to be a minus or this is supposed to be a minus. One or the other. I don't know. So I even said, okay, well, let me make this a positive 9, right? And then that's going to give me a negative 5 and a positive 4, and that's still not the same. So really, the way this is prime. I do believe it's a typo, but the way that it looks, it's prime. On H, no GCF. You would think for a second that it might be 7, but you got that negative 1 there, and there's no way that it can be 7. Let's hope this one works out better than the last one. So I'm going to pull out an x squared as my GCF. It's going to give me 7x minus 1. And here I'm going to pull out a 7. And that's going to give me a 7x minus 1. Okay, looking good, looking good. 7x minus 1, x squared plus 7. X squared plus 7 looks different, but there is no method there. It's not perfect squares or perfect cubes. So you're done. All right, let's go for a GCF. It's not 16. I think it's 4. Let me just do 54 divided by 4. Oh, no. So it might be 2. So 54 divided by 2. Okay, so your GCF is actually 2, and they both have x's, so the lowest one is x squared. So divide everything by 2x, put my 2x out front. That's going to give me 8x cubed plus 27. Ooh. Ooh. Okay. Am I done? I don't know. It's not a difference of perfect squares, but you know what it is? It is perfect cubes. So the perfect cube formula you have to have memorized. So a plus b. I'm using the plus because this is a plus. A squared minus ab plus b squared. So I need to know what a and b are. So it's whatever these are after they're cubed. So the cubed root of a at 8x cubed. Well, the cube root of 8 is 2. And the cubed root of x, third, is x. So that is going to be my a. The cubed root of 27 is 3. So that's my b. So now I'm just going to take my a and my b and put it in. So I have 2x plus 3. 2x squared. Now, make sure that all of 2x is a, so it needs to have parentheses. Minus 2x times 3 plus 3 squared. So now I just need to clean up that trinomial a bit, and that's going to give me 4x squared minus 6x plus 9. Now you may be wondering, oh, and you know what I forgot to do? Carry along my GCF. So this is the final answer right here. Now you may be wondering, can I factor this trinomial? It looks like a trinomial I can factor. We've been factoring them. No, you cannot. You can try it, but it's not going to work out. You will not find something that multiplies to a positive 36, but adds up to a negative 6. It doesn't exist. Now on J, my GCF is 5. So when I divide everything by, oh yeah, that's, my brain is one step ahead. Not dividing by 8, I'm dividing by 5. So I have a 5 out front, and that's gonna give me 8x cubed plus 1. Ooh, ooh, ooh. We have perfect cubes again. Addition again, well that's nice. So I have a plus b. There is no way around this. You have to memorize this. So now we just need to figure out what a and b are. So I have 8x cubed. The cubed root of that is 2x, so that's my a. And then the cubed root of 1 is 1, so that's my b. So now let's plug in. 2x plus 1. Again, the 2x needs parentheses around it. Minus 2x times 1 plus 1 squared. And I forgot my GCF again. And now I'm going to just clean up that trinomial. So I have 4x squared minus 2x plus 1. All right, that's all the homework. Tonight's homework is more factoring completely. I will go over it tomorrow in class, and you have a quiz on Friday. Trivia, next page. All right, here we go on the trivia. When it was first created in 1938, what was the minimum federal wage in the U.S.? I'll say that again. When it was first created in 1938, what was the minimum wage in the U.S.? Okay, see you later. Bye.